What up, what up, what up? Today the big shout out goes out to my former student Matt Kaloff, now a sophomore at the University of Denver. My boy, Matty K. Alright guys, today we're going to solve a system of equations by the elimination method. Previously we did the graphing technique and then we solved by substitution. Now we are going to use the elimination method. So we got to find the point of intersection of these two straight lines. So what we want is for the x terms to be opposites or the y terms to be opposites. So if you look at the y terms, we have a negative 1y over here. Whenever you don't see a number in front of the variable, it's assumed to be 1. So x means 1x, z means 1z, b means 1b. So what do we have to multiply negative 1 by so that it's positive 4? And that would be positive 4. So what we're going to do is multiply the first equation, both sides, by 4. Basically, an equation is like a seesaw or a teeter-totter. Whatever you do to the left side, you got to do it to the right side if you want it to stay in balance. So if you think of a seesaw when you were a kid, you can't put Taylor Swift on the left side of it and King Kong on the right side of it and expect it to stay balanced. So as long as we multiply the left side and the right side by the same number, we're going to get an equivalent equation. And that new equivalent equation is going to be 8x minus 4y equals 12. Now we're going to bring down that second equation as it is and put it underneath the new first equation. And now we're going to stack them on top of each other and basically just add like terms or combine like terms straight down. 8x plus 5x is 13x. Negative 4y plus 4y is 0. The y terms eliminate. That's why they call it the elimination method. See ya. Bring down the equal sign, and 12 plus 53 is going to give us 65. There we go. Now we're going to divide both sides by 13, and we get x equals 5. So the solution to our system, the point of intersection, is going to be 5 comma something. We got to figure out what that y is. So always go back to the original equations, but pick the easier one. Either one's going to work. Just since I already did the math over here, I'll use the second equation, but don't think that we couldn't use the first equation. So the 5x plus 4y equals 53. That's one of the original equations. We're going to take this bad boy, the 5 that x equals, and plug it in for x in the original equation. 5 times 5 plus 4y equals 53. That gives us 25 plus 4y equals 53. Now we've got to subtract 25 from both sides. We get 4y equals 28. And we're going to divide both sides by 4. And we get y equals 7. And we're going to put that back into our solution for the y. So the solution to our system of equations, or the point of intersection, is 5, 7. And you know it.